Hey guys, welcome to another episode of Learn with Jom series. For today's video, I'm going to have a tutorial bit about solving real-life problems involving semicircle theorem and Pythagorean theorem. So without further ado, let's get started. So we have the first problem here. Armani is walking in a circular park. He starts the edge of the park. He goes north at 4 meters until he arrives at the edge and goes west at 8 meters until he arrives at the edge. If Armani wanted to use the shortcut and wanted to go back from his starting position, what is the diameter of the circular park? So the first thing na imong buhaton din is to visualize the problem. So it says here that Armani is walking in a circular park. So the first thing that you need to do is to draw a circle. So we have this one. There. For example, that is our circle. It says here, he starts at the edge of the park. He goes north at 4 meters until he arrived at the edge and goes west at 8 meters. So inyong basahon sa ang murag given nato para ma-easy na lang dahil nato og identify kung unsaon nato pag-draw. Okay? For example, nakaingon diri nga goes west. So if kung diri ka mag-una, unsaon nimo pag-west, magawas na nun ka dito. So you should read first the problem. So in this case, since ningon man siya goes west, so atong edge probably is diri gikan. So going to undo that, let's say that he goes north at 4 meters. So let's say that he goes north at 4 meters. So let's, okay, and then there. Next, he goes west at 8 meters. So let's follow going west at 8 meters. There. So, until he arrived at the edge. If Armani wanted to use the shortcut and wanted to go back from his starting position, what is the diameter of the circular park? So we will use also this one. So, the given. So let's take for example that this circle is circle A. There. And then these points are, so how are we going to solve that? So let us have this one. In circle A, let the given, so he goes north at 4 meters. So let's put here 4 and here is 8. So let DC or let line segment DC is equal to 4 and let, sorry about that, and let CB, line segment CB, equal to 8. What is line segment BD? So with that problem, we are using the semicircle theorem. Why? Semicircle theorem states that when an inscribed angle intercepts a semicircle, then it is a right angle. Therefore, this is the right angle. Why? Again, that is an inscribed angle, right? It intercepts the semicircle, which is this, right? So therefore, the measurement of that is 90 degrees. So that is the semicircle. So find B. With that, since this is 90 degrees, this would be automatically a right triangle. With that, we could easily find the line segment BD through using the Pythagorean theorem. The formula for the Pythagorean theorem is a squared plus b squared is equal to c squared, where a and b are the sides of the triangle and c is the hypotenuse. Hypotenuse can be found opposite to the right angle. So let us now substitute our given. So we have first a, which is 4. So we have 4 squared plus b, which is 8. We have 8 squared here is equal to c squared. Simplify them. So what is 4 squared is 16. What is 8 squared is 64 is equal to c squared. Simplify them. So we have 16 plus 64 is 80 equals to c squared. To get rid of the squared, we need to square root them. So the square root of 80 is c is equal to 8.94 meters. So therefore, the diameter of the circular part is 8.94 meters. For this next problem, I want you to pause the video and try to answer it. Go. I think you're done answering, so I'm going to answer it with you. So the first thing that we need to do is to visualize and illustrate the problem. So an ice skater is ice skating at the circular ice rink. The ice skater starts from the edge and goes south at 3 meters until he gets to the edge, and goes east at 9 meters until he gets to the edge. What is the diameter of the circular ice rink? So let us first draw a circle. There. Since it says here, the ice skater starts from the edge and goes south at 3 meters, then it goes to the edge and goes east. So probably our starting point is here. And he goes there. That's it. The next instruction is the ice skater goes east at 9 meters. So let's go east until he gets the edge. So let's go here. So what is the diameter of the circular ice rink? So this is the diameter. Through the semicircle theorem, this angle would be 90 degrees. And this would be a right triangle. The first is go south at 3 meters. So let us identify this as 3 meter. And goes east at 9 meters. So let us say that this is 9 meters. So let's use math. So this is point M. This is point A. This is point P. And this is point H. So let us start. So in circle M, let line segment HT be equal to 3, and let TA, line segment TA be equal to 9. Find line segment AH. So that is the question. With that, we could use the Pythagorean theorem in order for us to find HA, or line segment HA. So formula again is a squared plus b squared is equal to c squared. So a is 3 So I have 3 squared plus b is 9. So we have 9 squared is equal to c squared. Simplify them. So what is 3 squared is 9. What is 9 squared is 81 equal to c squared. Simplify them. So we have 9 plus 81. We have 9p is equal to c squared. To get rid of the exponent 2, we need to square root them. So c now is equal to 9.49 meters. So therefore, the diameter of the circular ice ring is 9.49 meters. That's it.